This example shows the connection between the index of refraction, which is the ratio between the speed of light, or speed of light in a medium versus the speed of light in vacuum, and its connection to the wavelength. So the wavelength of the light wave in the medium would be the speed of the wavelength of the light in a vacuum divided by the index of refraction. And then the last connection we need is that the velocity is equal to the wavelength times the frequency. So if we look at the connection for the wavelength, and we use the relationship for the wavelength equaling the wavelength in vacuum over the index of refraction, we can see that the index of refraction then can be given by the ratio of the wavelength in vacuum over the wavelength in the medium. And if we use the numbers we're given, we have 633 nanometers for the vacuum or air and 474 in the eye. This gives us an index of refraction of 1.34. Notice that this is about the same as the index of refraction of water, which is 1.33. Now if we want to find the velocity of the wavelength in the medium, we can use that the velocity from the first equation we wrote is c over n, which would equal 3 times 10 to the 8th meters per second divided by 1.34, which is about 2.25 times 10 to the 8th meters per second. And finally, if we look at the third equation and we solve for the frequency, we find the frequency is the velocity over the wavelength. So this is 2.25 times 10 to the 8th meters per second over 474 times 10 to the minus 9th meters, which gives us a frequency of 4.74 times 10 to the 14th